Afternoon, everyone. In my previous lecture, I had started off with the function pointers or pointer to functions. So what is a pointer? Everybody knows that, which stores the address. And in case of pointer to a function, it will be storing the address of the function. So what is the address of the function? Address of the function would be
Name
nothing
of
but
the
name of the
name of the
function, of
function.
course. That is the method which we use to assign the address to a pointer function by the name of the function. But address of a function would be the address from where the code starts, function code starts. Okay, that is also stored in the memory. So it has also got some address. That is why when we call the function, it goes and goes to that memory address, looks at the instructions, and then executes it. Okay, so this much we have done. And then I showed you one example. I'll just again show you on the screen like that example. Okay, so you have seen that how to declare this pointer function or function to a pointer to a function. Okay, so is there any doubt about declaring that this thing? Suppose this is the function int square int definition is written over here. I think my screen is
Sir,
not visible
your
to you.
screen is
I'll
not
just
visible.
Sir, your screen is
Yes,
not
not
visible.
visible.
just
Your
realize.
screen is not visible.
Yeah, is it visible now?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
So
sir.
we also I also taught you how to declare this pointer to a function. So in this example, I showed you that this is the definition of the function and this is the prototype. So we have to write the pointer to this function. So what is the method? The return type, same return type you will mention, and within parentheses you have to write the name of the pointer which you want to declare as a pointer to this function. Okay. So what is required in that case? When you were declaring a pointer to an integer, what was required in that case? Asterisk was required? Yes or no?
Yes, sir.
Yes. So
Yes.
here you will put it within parentheses,
Yes,
this
sir.
asterisk, not without parentheses. I'll show you one example where one or two example where the meaning will change if I write it without this. So you have to write within parentheses, that's it. And then within again the number of parameters which are available in this function should also be same number of parameters and data type should be there in the this pointer to function. Is it okay? Any doubt about it? How you declare the pointer to a function? Please tell me.
No, sir.
No, sir.
No doubt.
No,
Okay.
sir.
Now this pointer has been declared. I could declare it inside this function also before using it. So pf is equal to ampersand square. Why I have written that? Pf is a pointer. So it is going to store the address of,
Square
Square
function.
function.
yeah, because it was a pointer to this function. Pointer should be storing, pointer to this function should be storing the address of this function. So address of this function, name of the function and ampersand. I could do it without using this ampersand also in the next same example. Even if you don't write this ampersand, if you say pf is equal to name of the function, that will be giving the address of this function. So now pf is having the address of this function. Now come over here. What has been done in this program? Sum of square values is done using pointer function. So how many numbers have been taken over here in this example? 4.
4.
4.
So
4.
idea is that square of 1 to 4, 1 square, 2 square, 3 square, 4 square. So I want to find the sum of it. So how it is possible? Suppose I don't use line number 16. Is it possible using line number 17 if I remove this comments? I can do
Yes,
it?
sir.
Yes, sir.
Yes, you
Yes,
can do
sir.
it. Sum is
Yes,
Yes,
equal.
sir.
sir.
They both have same thing.
Okay,
Sir,
so
I
I
can
can
generate
just,
it.
it keeps on adding and I get this result. But instead of this, I am interested in using the pointer to this function. So how I am going to use it?
Dereference
this pointer, and then whatever parameters are to be passed, you just pass the parameters. So because of this,
Sir,
now this PF is pointing towards which function?
Square function.
square function.
Okay, then this it is square function. So the definition will come into play. It will be active, and you are going to get the results. Is it okay? So
Sir,
that is
in
how
the
you have
S
been
plus,
able to use.
in the 16th line, sir,
Yes, please ask.
we have to still use a parenthesis for dereferencing that
Yes,
pointer.
you have to use.
Sir,
Okay.
Or sir,
I
it
will
is
just try
optional,
to
sir.
remove it and then see that thing also, which you have asked. Yes.
sir, if in main function we use int square and int asterisk pf, once again we declare the square variable and pointer pf.
Let me see. This is the example. So
Yes, sir.
first query was like this. If you do it like this, what will happen? It doesn't take. Okay. It doesn't understand what it is. Right. So that is how it has been defined. And that is how you are going to use it. Okay. So we are getting that answer. Now, what is your query? We will just modify the
Sir,
program quickly.
sir, in main function, after line number 9, we use int square and int ampersand int asterisk pf. Then pf will store which square, the function square or the variable square.
See, you are talking about this line number 10.
Yes, sir.
So this is the pointer which we have declared. I could declare it outside this main also immediately after this prototype. So just to show you that you have to use it before declare it before using it. So now you're saying this thing. What you want me to write over here?
Sir, after before line number 10, if we
Yes.
also declare variable square and pointer pf, तो सर ये जो pf है वो किस
No.
स्क्वायर
You
को?
want to declare this like this variable square.
Yes, sir. तो सर pf, हाँ. Yes, sir. And int asterisk pf, a one pointer also.
Then
सर pf किसके पॉइंट करेगा,
Square
स्क्वायर
की
वेरिएबल
spelling,
को या फिर स्क्वायर?
sir, देखिएगा आप.
अभी तो I have not showed address of anything. Have I scored?
Yes, in line number 13, pf is equals to ampersand square.
ये तो it's going to be some hodgepodge. Okay, so it's not like that. I can just do it.
Sir, square की spelling भी देखिएगा.
Is it okay now?
Yes, sir.
So what? Conflicting हो गया ना? Now here you have declared this PF.
Yes, sir.
Okay, and now either you have to make it some other this thing.
Okay, yes, sir. Now fine.
It's just controversial for this computer to read.
Okay.
Yes, sir.
So that is why we wanted to declare the pointer to a function in this fashion. Okay, then only it will understand. Okay. Right. So this program is okay. You can understand how to declare a pointer to a function and then how to use it. So we'll slightly move ahead and go to the next example. Let us see that our aim is not merely using one passing. Now we want to pass this function as an argument in another function. That is the aim we want to see. Okay. Now look at this example. First, I will not be going into the details of it, that how this has been declared and all that. First, let us see this main cout sum. Sum is a function, of course, sum is a function which we are calling over here. And then you can see as an argument what we are passing over here, square and cube. So these are two functions.
Square.
So we are passing functions as arguments. So in this case, it is going to sum when this will be square. So it is going to find the sum of this 1, 2, 3 and like that. So first three numbers squares will be added and you get the result. When cube is problem is like this, when you pass this cube, so accordingly as per the definition of this cube, okay, that although starting from 1, 2, 3 and 4, so it will be finding the cube and finding the sum. Okay, so is it okay or not? First tell me that. Have you understood this part?
Sir, instead of
yes,
pointer, can we use another for taking the
as an
input
argument.
as a function, as an argument?
Yes, that is how I am going to pass a function in this. Okay, as an argument. Now let us see. Go ahead, little one by one. So square and definitions are written over here. These are simple. You can understand this. Okay. Now come to this sum. Okay, this is one argument, which is a pointer to a function, and another argument just an integer. Yes. Ask. You had raised some point.
Yes, sir. There is doubt in this pointer to function declaration. How to use?
Okay. Don't worry. You are going to tell me. Now I'm passing. This is the definition. Is this the definition? Now what I wanted to pass? I wanted to pass this square. Isn't it? I'm passing square, this function. What this function is, like if I write the name of this function, what it is giving me? Address?
Address of the function.
Okay. Now in the definition, I have to write a pointer to this function. Then only it will accept. If the pointer to this function is available in the definition, then only it is going to assign this address to this pointer, isn't it?
Yes, sir.
Yes. Now, why I have written this pointer to a function in this way? What were those functions? Square and cube. So what is the definition? Int square, int k. So how do you write the pointer to a function? Int, parenthesis, asterisk, and then you give some name to that pointer. In this case, again, it is pf. And then how many parameters are being passed in this function? 1. So I could use some other name also. Instead of k, I could use some other also. So you are writing like this. Now it is correct?
Sir. So sir, PF same pointer is pointing towards two different functions.
Right. Whenever I will pass accordingly, whatever address is being passed, it will start pointing towards that function. In this line, it is pointing towards square, so it will act as per the definition of this square. If the address over here, this parameter is changed to cube, so it will be pointing towards this cube definition.
Okay, sir.
Okay. Yes, that is the idea. Like, so if the pointer is not there, then this definition, I would have written two different definitions for sum 1, sum 2, isn't it?
Yes,
okay,
yes,
so
sir.
Here I can use single definition, but here when I'm calling it, I'm just changing this argument. So whatever function definition I want to bring it into action, so I will write that name. And of course, in the definition of this sum, the pointer has to be definition of this, the declaration of this pointer has to be as per this. Okay. Is it okay for everyone? This part, how this pointer function has been written as an argument in this, and when I'm calling it, I'm just writing the name of the function over here.
Sir, instead of a pointer to a function, can you use another thing for taking square as an argument, function as an argument?
How you are going to do it?
Can we use a simple int square and two parentheses and comma
No,
int
not
for
like
an
that.
argument?
I have not tried that part. Maybe you can try.
Okay,
So our main purpose was that whenever we want this to point to a different definition, so it should act as per the required definition of that function. Now int s is equal to 0 for this for loop is again there, and the same thing which we did in the previous example, sum asterisk pi. So can I use this part? Asterisk pf.
Yes, sir,
this
it
definition.
will different.
Yes,
Square bracket
available. This is passing as an argument, so it is available to this function also. And then now it is square over here, and then this square will be. When the in this calling cube is there, it will be acting as per this, and I'm getting the results like this. Is it okay?
Sir, I
Yes,
can.
sir.
Sir, I am unable to understand the s plus equal to asterisk pf. This one, yes, sir.
This calling is okay? How I'm calling it?
Yes, sir, I can understand this.
Now what about this? Where is the doubt?
Sir, this s plus is equals to asterisk pf into ia. Sir, what is this?
This is it. Now in this function, okay, I go back. I just now explained you this part in this example.
Yes, sir. This one is doubt.
Okay, still doubt. Here I have to call this function to get the result. Suppose I'm not using line number 16, I'm just using line number 17. So you would have written this s plus equal to square I. Is it okay?
Yes, sir, I understood the complete thing, sir. Thank you.
Okay. Now you got it, na? So to get this kind of thing in terms of the pointer.
Yes, sir.
And the point in this case, the pointer was pointing towards this address of the square. So it went and looked for the definition of this square. Okay. So same thing is happening over here. Now it is clear to you. Is it clear?
Yes, sir. Yes, sir. Completely clear, sir.
Yes, good. So we can move ahead. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Now, this was the example which I showed you just now. Okay. So let me show you why I'm writing within parentheses this part. Why I'm writing within parentheses this part. Okay. Suppose I do not write it this like this. Then what it means? It's a pointer to a function or it's a function? Just tell me that. What it looks to you? How do you declare a function? You're declaring a function like this. But if I write it like this,
it's like a function.
And what it is returning? What is the return type of this function?
Int.
Integer.
An address.
Integer. Address.
Pointer.
Address.
Pointer.
Extension of it.
Pointer. Address. It
Pointer.
will return some address or pointer. Okay. I will show you that example also. So that is why just to avoid that it's not a function, it is a pointer. And if I had not mentioned those parentheses, then it would have meant that it is a function which is returning a pointer. See, it's not going to understand what is happening. So even the compiler has been designed like this. When you put it in this way, only then it will understand. So let me show you. Quickly, I will go through it. So here it is returning. I will just show, this is the prototype. You can see I'm not using any parentheses. This is just a function which would be returning what?
Address.
A pointer. Yeah, a pointer or address. Yes. Now let us see the definition. Come over here. 2 pointers have been passed. You understand this part. If pointer dereference it and then see that if m is greater than the value is greater than this. Okay. Compare the values of it, dereferencing, and then if it is this, just a simple example just to show you that how the returning the address, and it will return the m. M is a pointer, so if it returns m, it means address is being returned, the pointer is being returned. Now let us see over here, 2 variables were there, x and y. Yes. Now I declared another variable max, so that is a pointer, and initial value is null, not pointing towards anything. Now let us see what it is going to return. This function. Look at the definition.
Pointer.
Address.
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 So if I say max equal to some address, so is it okay or not? Max is a pointer, so it should be storing some address, and in this case, it will be returning some address. Okay, so what should I do? Get max, calling this function, and if passing 2 pointers over here, so what should I pass over here? Address of some variables? Yes or no?
Yes, sir.
Yes, sir. I showed you in the example of swap also. So we discussed quite in that case. So if anyone has tried that, changing the address also changes the values, or did anyone try that? We can discuss it later also, but here addresses are being passed. So they'll be assigned to this m and n. Yes. Now within this I am dereferencing asterisk m. So what it will give me? What it is going to give me?
Value of x.
102.
Okay. So is it greater than y?
No, sir.
No, sir.
Okay. So what it returned?
It returned the address of y. So the address of y was returned, and therefore max was pointing to y.
It went to the else part. Address of y was returned. Yes, y was returned. So max is having the address of y. Now if I dereference it, so what I'm going to get? Value of y. Okay. So you can see that this, if I write int asterisk in this fashion, it means that it is going to return a pointer or an address. That is why in our definition, we did not write it this way. Okay. Any doubt? Resume.
Yes, sir. Sir, in the previous slide, oh sorry, the previous, no, sir, the getMax one.
Getmax one is not here.
Yes, sir.
I will just go back to this. Yes.
So sir, getMax is a pointer.
GetMax is not a pointer. GetMax is a function. And what is the return type? Return type is this much. Okay.
So max is a pointer.
Max is a pointer. Yes, of course.
Yes.
That has been declared. Okay. So
that is this function is storing the address of that variable getMax.
No.
So it is a
storing
function.
Just repeat it again.
So getMax is a function which is storing the address of value that we have declared.
Which value you have declared?
So x and y in the main function.
GetMax is a function where two pointers are being passed, and some definition is there. Yes, definition is there. Then this function is going to return something. And what it is going to return? It is going to return a pointer which will be pointing towards some integer. When I write int asterisk, now suppose to declare it as a, it may not be correct over here, but to declare it as a pointer, I will write something like this. That is what I wanted to tell you.
In the square bracket.
No.
Parenthesis.
Wrong parenthesis.
Okay. Yes.
That is why I am writing within this. Okay.
Okay, sir.
Otherwise, the meaning will be that it will not be the declaration of a function. It will be it will not be the declaration of a pointer to a function. It will be a function declaration. Suppose I had written int asterisk pf parenthesis int. Okay, then should I show you again? Okay. This is another definition. Yeah, over here. If I now look at it after going through that getMax, it will be like pf is a function. I am trying to declare a pf as a function which would be returning a pointer. So that was not my aim. Okay. Yes or no? Please tell me.
Yes, sir. Clear. Clear, sir.
Okay. So I can move ahead. Everyone agrees to it. Maybe you need to do some practice it, and then some questions are there in your tutorial on pointer functions also. Okay. So yes. Now this is another example. I think after this we can switch over to a new thing called 2D, creating 2D dynamic arrays. So let us first understand this part, how it is happening. So here 3 functions are there in this. Prototypes are there and definition for all these functions. It could not fit on one slide, so rest of the things have gone into next slide. So subtract, product, sum, simple ones. 2 parameters are there, sum of them, product of them, and then subtract them. Yes. Now come to this. Some variables have been declared. I, A, B, like that result. Now, is it a pointer to a function or not? Just tell me that.
Yes.
Yes, sir.
Yes, sir.
And in
Yes,
fact,
sir.
array of pointers to functions. Array of pointer to functions. One would be pfun 0, another would be pfun 1, and another third one will be like that.
Sir, it is an array to a function. Array of pointer to a function.
Pointer to functions. Array of array of pointers, and these pointers, in this fashion, if we declare the pointer, there will be pointer to some functions, isn't it?
Yes, sir.
Now we change the subscript 0, 1, 2, like that. 3 pointers have been declared, and they will be pointer to some function. So p1 0 could store the address of some product or subtract, yes or no?
Yes,
Some
sir.
of the
Yes, sir.
It could store the address of either
Yes.
sum or product or subtract. It could store. Why? Because return type is int over here, and then asterisk p1 is there, 0, of course, and then two parameters are there in all these functions. So it has been declared as a pointer. Now what about p1? It could store the address p1 0 or p1 1 or 2. It could store the address of any of these functions. So in our example, we have stored the address p1 0 is equal to sum has been stored. And in this another pointer to this function, product address has been stored. And in this p1 2, address of this subtract function has been stored. Done? Is it possible or not?
Yes, sir.
Yes, sir.
Now we are
Sir,
using a for loop.
in the for loop we have to write result बराबर d asterisk p1.
But if we are using in this way, this subscript fashion, we don't require. Either you have to
Okay,
write, we can try to modify it and see. Then working. And let us see if gets interpreted or not. Yes. So, and if we don't use it, it will mean the same thing. So for the sake of simplicity, what you have learned, you can keep it like this also. Okay. Right?
Sir. Sir, in line 13, asterisk p1 3, the 3 is the size of the array.
Right. 3 pointers have 3 function pointers have been declared over here.
Okay, but in line 15, the p1 0 is not the size of the array, 0.
No, this is not the size of the array.
So it is indicating the number of the array.
Yeah, the pointer, first pointer, second pointer, third pointer, like that.
Oh, okay. Yes, sir.
Now you come to this. This has been declared. Now what is happening? If you dereference it, to which pointer it is going to point? If it is 0.
Sum.
And A, B you are passing. What it will give you?
15.
15 plus B.
15. Then next time what it is going to give you?
Product.
50.
50. And then
Subtract.
that is right.
5.
For loop is over. All the pointers have been used to which they were pointing. So in this case, they were pointing towards different functions. So it got executed as per the definition, and you got the result. Now, what is happening in this case? You can see next time p1 1. So what you want to do?
Product.
And what about p1 0 a comma b?
Sum
A
of
plus
n.
B.
Sum of a comma b.
Sum is this, I think, 15.
Yes, sir.
And then 2 is subtract.
Subtract.
So you want to find the product of sum and the subtract. That is how you got it. Okay. So now all the combinations you have seen regarding this function pointer. You have seen the function pointer array also, and you have seen that why we have to put this thing in parenthesis, so that the interpretation is not like this, that this is a pointer returning or address returning function. Okay, now we go to the new topic. Are you clear about that how to declare 1D array dynamic arrays? Before I move on to the next slide. Do you remember that?
Yes, sir.
So you had used some pointer to declare the dynamic arrays, 1D arrays. You had declare a pointer is equal to new and int, and within the box bracket you had mentioned the size of that array. Okay. Now we want to create a 2D dynamic array. This was about 1D, one-dimensional. Is it a static array or dynamic array declaration?
Dynamic array.
Dynamic.
And what's the name of what would be the name of array in this case?
IP
Name of
array.
the pointer.
IP array.
Right. And why you wanted to deallocate it?
Release the
That
memory.
was
To delete the memory.
release memory.
Okay.
Then
Release
memory leak.
memory.
And why it was important to release the memory?
Sometimes it
To
takes
avoid
lots of
memory
values.
leakage.
Not
Because
important for
memory
us.
leakage.
Okay, memory
We don't
leakage is
To
there, but
avoid memory.
so that you can reuse the same amount of memory is available to you throughout the program, so that it can be reused. Once you have used it, allocated, and you think that the job of that thing is over, and you can deallocate it, and the same memory space can be used by some other purpose or some other array, dynamic array. Okay. Now let us see how to declare 2D arrays. Okay, suppose there was 3 by 2 array was there. 3 means 3 rows and 2 columns like this.
2 columns.
Now I want that each row there should be a pointer which should be pointing towards each row. Then suppose you want to create this 3 by 2 array as dynamic array. So what you want to create this row, first row? What do you require to create this a row? How you created it as a 1D array? What was required? Int ptr is equal to new int, for example, parenthesis, some size.
Yes, sir.
When you declared this as int asterisk name of the pointer is equal to new, and then int, and then 3 over here. So what it meant to you? 3.
3 rows. No, 3 conjugate, 3 columns.
Yeah, a row was only
1.
1D array. Row is only 1. Okay, 3 elements are there. Consecutive elements are there at contiguous memory locations. Is it okay now? Yes. Now think like this. In a 2D array, a 2D array is nothing but array of arrays.
Yes, sir.
Yes, sir.
Now, what about this first row? How I am going to allocate space for this row? What is the way to allocate space for this first row so that it can hold 2 elements? I should have a pointer. Yes or no? Using a pointer, I can allocate space and another pointer allocating space for the second row, and another array, another pointer for
Yes, sir.
allocating space for the third row. Yes, it means that I want in this case 3 pointers. Yes or no?
Yes, sir.
Yes, sir.
Array of pointers. I need array of pointers to allocate space for each of these rows of this 2D array. Yes?
Yes, sir. Got it.
Got it? Yes. Now, how do I create this array? Nothing is existing in the memory. How do I create this array of pointers? These are array of pointers. So how do I create them so that they start existing and they start pointing towards these rows? So what should I do? How you were creating the dynamic array?
Int pointer new.
Yes. So you were using a pointer to create. So
Yes, sir.
Again, to create this array of pointers,
Yes, sir. You need array of pointers.
this array of pointers is required to create these rows. Now to create this array of pointers, I need another pointer. Then only this array will be there. This is in contiguous memory location. Then only
Yes,
I
sir.
will be having.
Yes, sir.
So what kind of pointer it is?
Pointer to pointer.
Pointer to pointer.
Double pointer.
Double pointer. So this is array of pointers. So I need double pointer so that it can point towards this. Now let us very coolly look at the all the syntaxes to create this dynamic array. Look at it. The diagram is still here. I'll try to correlate everything, and some values were entered, or it was like they were allotted fields, the arrays, and we got it. I've got the live program also with me. Now look at this. First job is to create this array of pointers, isn't it? If they start existing, then using these pointers, I'll be able to create these rows of that 2D array. Now, how do I create this array of pointers? Int new, of course, yes. Now, why I'm writing this? Int double asterisk. Why I'm writing this? IP array is the name of the pointer. It's a double pointer. New int asterisk 3. What it means? It is going to create an array of pointers. As soon as I write this line number 6, array of pointers will be existing in the where? Heap memory, isn't it? It will be start. Yes.
Yes, sir.
First thing I wanted
Yes,
this.
sir.
First thing I wanted this. Now, what should I do now?
So the next array of 2 columns for each pointer.
Yes, now I want this. Now I want this. So how this 0, 1, 2, 3, what will be the name of this array?
So name of the double pointer.
Double pointer,
Yes.
IP array. So if I say IP array 0, IP array 1, IP array 2. So if I say IP array 0, I'm using a for loop, new int 2. So it means that which row will be created in 2D array?
First row.
The first row.
This will get created. And in this way, line number 8 and 9 will create all these rows. In this way, I am able to create a dynamic array, 2D dynamic array whose dimension is 3 by 2. Okay, so first double pointer we are using will be the index over here, or the size you will mention, number of rows. Why? Because we need to create so many pointers so that each of these pointer would be able to create a row. So that is why 3 is there. Now, next step, using these pointers, I want to create these different rows. Okay. And in each row, how many elements I want to store?
2 elements.
2 columns.
2.
That's why I'm doing. Now this way start existing. Now how to fill it? It has created the dynamic array, 2D dynamic array whose size was in this case 3 by. So you can change it and then now you can modify it that you can give the size also from your side, how many rows and columns you want. Say this number can be variable. Input from your side can also go over here. Okay, in this dynamic array, it will not ask you for const integer or something like that. Now is it clear about this? You'll remember?
Yes.
Okay. Now it is simple. Like just to fill it, IP array, both the subscripts are changed and then some values assigned to it. Okay, it goes to the respective rows and column. And output again you can use it as a okay. And we get everything. Now to delete, deallocate. So first you have to deallocate this thing like this, all the rows, and then this is also existing in the memory. So finally you will use IP array to delete this array of pointers also. So these individual pointers are used to delete this. So you can IP array 0, 1, 2, 3, it will delete all those things. In this case only 1 is taken, and then finally delete IP array is also required because it is going to delete this array of pointers. This array of pointers was used to create, each pointer was used to create these rows in the memory. Okay. Sure. I can view this 2D. Yeah, this is slightly different here, so you can, yes. Yes.
Sir, can you please explain the array that you start? The starting array of first column. Double pointer, वो समझ नहीं आता.
You know what is a double pointer? Suppose you want to store the address of some pointer. Pointer is storing the address of a variable. Okay, and you want to store the address of a pointer. So what do you require?
I need another pointer, sir, to
another
store
pointer.
the address.
So if you want to store address, okay. So that is why I've used pointer to a pointer. Now I wanted to create this array of pointers. So if I don't write asterisk over here, what it is, it will not be, these will not be array of pointers. I wanted these array of pointers. So first it will create the array of pointers. Since these are pointers, so I needed double pointer to create this array. It's all dynamic. Okay, first I have to create this. Then once this pointer have come into existence, so using those pointers, IP array 0 is one pointer, so I can create this. This row will be created, then this row, wearing this. Okay.
Oh, sir, one more thing. If we place in the previous slide, if we place 27th line before the 26th, sir. That's why.
That we can see over here. I've got a different this thing. I can locate that program also. 2D. Now quickly here you have const then first declared and then created these rows. Okay, here the size you can give from your side also. Then same thing has happened. All the rows have been created as per the number of columns given by you. Then you have initialized this 2D array. 4 rows and 4 columns were there, and then you are using it to delete this. So basically, for loop was there for this. Actually, first you should delete those this thing. Why I'm using this first? Just tell me. If I'm not using it, then what will happen? Pointer array, and I'll not be able to locate these
Element.
Yes, yes.
I think, sir, the memory will still store
yes.
the address of the rows and columns.
Yes. Those will still be hanging in the memory. Okay. It will not be giving me any error, but that is what you wanted, na? X and this. You wanted this?
Yes, sir.
Then double pointer is going. Error will not be there, but I don't know what is happening inside it.
Okay, sir. I have to try at me. Okay, sir.
So this was all about this pointer to functions and double point this 2D arrays. So next topic would have been for me today this structures. Okay, so structures is nothing but like in the arrays we have been storing all the homogeneous data type. In structure we want to store heterogeneous data type where I'll explain in detail also in one of the lectures. So how to declare it, what is the syntax of it, and for example, we want to store date. So day, month, year will come, and then how to declare a variable. It could be like name also could be. Suppose we want to declare a structure for a student. So we would be storing the name of the student, and that will be string in the same this structure, and it could be date of birth of a student also. It could be the enrollment number also, or so many things, height, weight, everything we can store together. So in case of arrays, we could store only homogeneous or heterogeneous data type.
Homogeneous.
Now, in case of structures, we will be storing heterogeneous data type also. So, suppose struct, how do we declare it? And this will be a user-defined data type like student, and here it will be long int or int. Okay, so this is integer type. Then age is again integer. Then char gender, it will be that character type. And we could take it as float also. Okay, height and weight as float, like that. So it is a heterogeneous. And then how do we declare a variable which is of type student, and then the name of that variable. So we'll go into detail and how to assign values to this S1 variable. Okay, there could be another, for one student it could be S1. So this set of values will get stored in this S1, and second student will be S2. So these set of values will be stored for that student, like that. Okay, so we are going to study it in the next class. So I may post it in advance also this site. So any queries? I'm going to close for now.